Hello viewers, welcome to the Advanced class. Today we are going to work on the analysis of variance known as the ANOVA. So I'm going to put you through the basic model of the analysis of variance and also on the decomposition of the sum of squares. So generally we should know that the model for the analysis of variance is Yij equals mu I plus Eij. And one of the basic reason for studying this analysis of variance is for us to look, the application of ANOVA is majorly used in any design of experiment, be it in the agriculture or in any other field. So we are going to look at the treatment effects. How does the treatment performs? Is there any difference in the treatment or there's no difference? So these are the things in which we are going to look at. But there's a need for us to know the statistical background regarding this. So here we have our YIG. This talks about what? The observation, okay? And we have our mu high. So the mu high is the same thing as the what? As the treatment mean. So this is the mean of the treatment being assigned. And we have our EIJ, which is also known as what? The random error. So mu high, this model can also be written as our Yij equals mu plus tau high plus Eij, where our mean high, which is the treatment mean, can be stated as the what? The overall mean, and also what? As the treatment effects. So our mean is known as the what? Overall mean, and our tau high is known as the what? The treatment effect, where our EIJ is still the same thing as our what? Random error. Because statistically speaking, for every experiment, we should give room for what? Error, because no experiment is perfectly carried out. So there is possibility of you having an error. So we need to estimate the error also. So now with this is going to give us a guide on how to decompose our sum of squares, in which all these general formula we know about ANOVA. How do we get this formula? This is what we want to work on. So this is going to take, looking at this, if you estimate this population mean, which is known as the overall mean, okay, which is also known as what? Our y dot bar, okay, the estimate of it. So don't forget that we have our observation equals this. So this is what I'm going to use to estimate my what? My sum of squares. So now, under the decomposition of the sum of squares, I have that my SS total. When I use the word SS, this means what? Sum of squares. So that's the meaning of SS. So for the total, that means for the general treatment, so we have our SS total to be double summation, where my I sum from what? 1 to what? A, and my J sum from 1 to N, Yij, okay, which is the individual observation, minus the what? Minus the overall mean square. And if you look at this, don't forget that our I sum from 1 to what? A, and J sum from 1 to N. So when we get to the two-way ANOVA, which is known as the RCBD, which is the randomized completely block design, then we can talk about the blocking effect and also about the treatment effect. But in this case, we are not considering the blocking. Okay, we are only limiting it to the what? To the treatment effect. Now, we want to decompose this, okay? So what we want to work on is the decomposition of our what? Of our SS total. So how do we decompose our SS total? So that's what we want to work on. So we have our SS total to be double summation. In this one, I'm going to omit the use of the notation that is I to A, J to N, okay? But when I need it, I'm going to make use of it. So I have Yij minus Y bar dot squared. So decomposing this is the same thing as saying my double summation Yij introducing minus yi dot bar plus yi dot bar minus y dot bar all squared. Don't forget, this is what we have initially. So my yi dot bar, this is known as what? Treatment mean. This is the same thing as the treatment mean, okay? So minus yi dot bar plus yi dot bar, it can cancel out, which shows that this is still the same thing as this. Just that for me to get my decomposition well, I need to introduce the treatment mean. Okay? So using this, if you want to distribute this, that means factorizing this, or let me say expanding this. Okay? This is the same thing as saying Yij minus, just take these two, okay, call these two A. This B is like you having A plus B. And don't forget, if you want to factorize A plus B to the power of 2, you are going to have what? A squared plus B squared plus 2AB. Right? So the same thing is what I'm going to use there. So you are going to have A squared plus B squared plus 2AB. So that's what I'm going to use here. So my A, which is Yij minus yi dot bar squared plus double sum yi dot minus y dot bar squared plus 2 double sum, which is AB. Now we have Yij minus yi dot bar minus y dot bar. This is the same thing as the cross product, right? Okay. A squared plus B squared plus 2AB. This is just what I did. Now, leaving these two, let's just talk about these cross products. Okay? Now, we have 2 double sums Yij minus yi dot bar minus y dot bar. So, this is the same thing as you having 2. Let this be intact, then let's distribute this. So let me just go down a little bit. So here I have 2 double sum Yij minus yi dot multiplied by yi dot minus 2 double sum Yij minus yi dot multiplied by what? Y dot bar. So with this, solving this This is the same thing as you having 2, and don't forget, I ranges from 1 to A, my J from 1 to what? N. So my I sum from 1 to A, my J from 1 to N. So I have 2 Y bar I dot summation, okay? I from 1 to N. Since this sum from 1 to N, so my I sum from 1 to A. So since my J sum from 1 to N, then I can say this is the same thing as what? We adding NYI dot R minus NYI dot for this. Okay? When you take this sum to go in here, you have the same thing as this. Don't forget that mathematically that y bar is the same thing as summation x over n, right? That is summation x equals n y bar. We have this mathematically. So this is what I'm making use of here. So minus this denominator, I have 2 y dot bar, okay? So here I have the same thing will be used, sum from 1 to A, NYI dot minus NI dot bar. So looking at this minus this gives 0, this minus this gives 0. So this shows that we have what? 2 into bracket 0 minus 2 into bracket 0 equals to 0. So coming up to this, we can see that the cross product is the same thing as what? 0. So we can see that the cross product is the same thing as what? 0. So we can say from here, I think I will have to clean this. So this is what I've been able to prove, that this cross product is the same thing as 0. So cleaning this for me to be able to show what I want. Okay, let me just clean this. So that means the cross product does not exist again. So double sum yij minus y dot bar squared. This is the same thing as our what? SS total, which is the same thing as what? SS error. This is my SS error plus, sorry, S dot SS treatment. So for the decomposition of the sum of squares, your SS total is the same thing as SS error plus what? SS treatments. So this is what you have here. And what we get here will be used. Okay, let's talk about the mean square error, mean square total, and mean square treatment also. So with that, we can draw our ANOVA table. So I can do. So I'm going to do this. So we have our mean square total. So there's nothing like mean square total, mean square error, which is also known as what? SS error, over the degree of freedom. How do we determine the degree of freedom? Yeah, before I can proceed with this, I have to give a little analysis regarding degree of freedom. Take for instance, we have an experiment before even moving straight to the mean square error. Take for instance, just take note of this. So we are coming back there. I'm a farmer. Okay, I have a plot of land. So in my plot of land, I intend to plant a maize. Okay, so this is my first treatment. I have my Y1. This is the first plant. I have my what? The second observation. In the second column, first row, third column, and I also have what? First row, fourth column. Okay? So I have the same thing here, 2, 1, 2, 2, 2, 3, 2, 4. Okay? 3, 1, 3, 2, 3, 3, 3, 4. So here I'm having plant A, B, and also C. So these are the plots. Okay? Now, with this is the sum. I have my yi dots. This is the sum for the first row, for the second row, and also for the third row. Here, I can have the mean, which is the same thing as yi dot bar. That is this divided by what? 1, 2, 3, 4. Here, you can have your y2 dot bar, and here, y3 dot bar. And overall here, this is the same as y dot dot, which is known as what? We call this the grand mean, or the overall mean, right? You can call this the grand mean or the overall, no, sorry, the grand total, or the overall total. So y dot dot bar is called the grand mean, or the overall mean. So this is what we have. So for you to get your mean square, don't forget the A stands for what? For the row. I stand my high start from what? 1 to A. My J, which represents the column, 1 to what? N. So my A is for the row, my N is for the what? The column. So if you want to know the total units in this case, total units, let me call that capital N, is the same thing as what? Number of rows times number of columns. So we have how many rows? 3 rows multiplied by what? 4 columns. In this experiment, here I can say my A, in this experiment, A is 3, N, which is column, is what? 4 columns. So my N is the same thing as A multiplied by small n. So in this experiment, it's going to be what? 3 times 4, which is 12 units. So for our mean square error, or mean square error, yeah, is the same thing as SSE over n minus a, while my mean square treatment is the same thing as what? SS treatment over what? Over a minus 1. So for your F statistics, for our F statistics, we call it the F observe. You use the same form, you use the formula MS treatment over what? MS error. So you as a statistician or as a consultant statistician, so although we have some softwares to do this, you can use your SPSS, R, SAS, and some other softwares like that to do this. But you as a statistician, we call upon, once you calculate your F knots or F observe, so the value of your F observe, for you to determine if the experiment can be rejected or you do not reject the hypothesis of the experiment. You know, your hypothesis under the normal null hypothesis, your normal null hypothesis is that what? The treatments are equal. That is the null. But your alternate hypothesis is that at least one treatment is not equal to 0. That's the alternate hypothesis. So there's a need for us to get our F table value. But nowadays we don't make use of F table. Although you can still make use of F table for examination purpose, but we use P value because when you run the software, after giving you the value for your F observe, immediately you are going to get a p-value. Then you can make your conclusion based on your p-value. But if you want to calculate your f tape value, then you can make use of what? F, the degree of freedom depending on your alpha, okay? Level of alpha, I don't know, maybe you are using 0.05, but you make the degree of freedom here is going to be what? The degree of freedom of the treatment, because here you're having MS treatment as the numerator. And what degree of freedom of the MS treatment, which is A minus 1. And the degree of freedom for the MS error, which is what? N minus A. Okay? Then, depending on your level of alpha given to you, okay, you can use 0.05, you can use 0.01, depending on how the experiment, how you want the experiment to be, okay, and the level of alpha you are considering for the experiment. Now, what are the conditions for you rejecting a particular experiment, your hypothesis, or you not rejecting your hypothesis? This is the condition. That is, if your F observed, the value you calculate or F calculated is greater than your F table value, okay? If it is greater, you do what? You reject H naught. So when you reject H naught, then your conclusion is that there's significant difference in the what? In the means or in the treatment means. That means there's significant difference in the treatment means being compared in the experiment. Okay, but if otherwise, if it is not greater, maybe it is less, the value is less, then you do not reject. You do not reject. The same thing with p-value. In p-value, you compare your p-value with 0.05. And if the p-value calculated is less than 0.05, you are going to reject the null hypothesis. But if your p-value is greater than 0.05, you do not reject the hypothesis. So that those are the conditions. Now, typically, we have ANOVA table as this. Under your ANOVA table, we have the source of variation. We have the degree of freedom. We have the sum of square. We have the mean square. And we also have the what? The F. For the source of variation, we have the treatment. We have the error. And we have the what? The total. So for the treatment, the degree of freedom for the treatment, don't forget, is what? A minus 1. For the total, we have what? N minus 1. So, for you to get your error, the degree of freedom for error, although I said N minus A, but how do we get N minus A? You know, don't forget that treatment is the number, A is the number of rows, just subtract 1. For the total, which is AN, okay, that means you calculate all the units, subtract 1. But for error, you calculating error is the same thing as saying degree of freedom of total, which is N minus 1. Okay, equals to the degree of freedom of error, let's call that E, plus the degree of freedom of what? Treatment, which is A minus 1. So to get the value of E is like saying N minus 1 minus A plus 1. So minus 1 plus 1 cancelled, you have N minus A. That's the degree of freedom of what? Of error. So this is the same thing as what? N minus A. Also, to get our sum of square, don't forget the sum of square for treatment. The formula has been given to be double summation yi dot bar minus y dot bar all squared. And also, For the SS error, double sum yij minus yi dot bar all squared. And for the total, double sum yij minus y dot bar all squared. And for your mean square, is the same thing as what? SS treatment over a minus 1. For the error, SS error over n minus a. And for your F value, your F is the same thing as MS treatment over MS error. That's all. Then you are done. Although, for calculating the sum of square treatment, we have an alternate formula. Here I'm saying SS treatment is the same thing as what? Double sum yi dot bar minus y dot bar all squared. You can also add it as what? 1 over, okay? 1 over what? You can use 1 over b, which is the number of columns, okay? Summation yi dot squared. Not per this time, we are not taking the mean, just the total. Minus what? Y dot over what? N. So we are going to end the class. Oh, sorry. Here I need to put squared. So we are going to end the class now. Don't forget to subscribe. See you next time.